Alright, so now we're going to do more practice with increasing and decreasing intervals of quadratic functions. Jump right into it. So I want you to find the minimum or maximum value of the following function, and then I want you to identify the domain, the range, and where the function is increasing and decreasing. I'll give you a hint if you are totally confused. You're going to need to find the vertex to do this. So, although the problem's not asking for that, that's really what you're going to need to do. Pause the video, try to do this, unpause when you're ready to discuss. Alright, so hopefully you got there's a minimum value at -1, domain is negative infinity to infinity, or all real numbers, range is -1 to infinity, including the -1, the decreasing intervals are negative infinity to 2, and the increasing intervals are 2 to infinity. If you are confused on that, let's talk about how I got that. So first I found the vertex was at the point 2, -1. How did I do that? Well, I know that h is opposite of b, and b was -2 over 2 times a. A was positive 1/2. That simplifies to 2. Then k is f of h, or f of 2, so I plugged in 2 to the equation, and that simplifies to -1. So that's how I got my vertex. Since the a value is positive, I know that it's going to be a minimum, and the minimum value is the k value of the vertex. So that's how I got the -1. The domain is always negative infinity to infinity. The range is going to be is going to relate to the minimum or maximum value. Since it's a minimum, that's going to be the lowest point, so it'll be -1 to infinity. And since it's a minimum, I know that the general shape of the graph is going to look like this, right? And so the left-hand side is going to be the decreasing, and the right-hand side is going to be increasing. So that's how I came up with negative infinity to 2, 2 to infinity. And the 2's are based off of the x value of the vertex, because remember our increasing and decreasing intervals are related to x values. Next one, same thing. Try this on your own. Pause the video, unpause when you're ready to check. Okay, so hopefully we got the same answers that I did here. The minimum value is -19, the domain is negative infinity to infinity, the range is -19 to infinity, including the -19. The decreasing interval for this problem is negative infinity to -2, and the increasing interval is -2 to infinity. How did I come up with that? First I found the vertex again. H is opposite of b over 2a. So -16 over 2 times 4, that reduces to -2. Then k is f of -2, so, or in this case, sorry, that should be a g. So let's say g, since that's a function, g of x. G of -2, so 4 times -2 squared plus 16 times -2 minus 3, that is -19. That's how I got my vertex. I noticed my a value is positive, so I have a minimum again. That's how I know my minimum. The range is going to start at the minimum, and then the decreasing and increasing intervals are separated by the x-coordinate of the vertex, because again, they relate to x values are there showing x intervals. Any questions? Alright. Okay, next one. I want you to try this. So it's not exactly the same as the problems we've done, but just think about the information you're told. You're going to have to read a little bit, I know. Remember, you got to read left, right, top to bottom, 3 words of a sentence. See if you can answer the question. Pause the video, try it on your own, unpause when you're ready to discuss. Alright, so here, hopefully you you got the same answer I did. It's going to have a maximum value. The axis of symmetry is x equals -5, and a is going to be negative. How did I come up with that? Okay, well, if I know the quadratic function is increasing to the left of x equals -5, then it's going to look something like that. That's increasing, right? And then it starts decreasing after -5, or to the right of -5, so then it's going to decrease. So I can see this would be a maximum. And that occurs at an x-coordinate of -5. I don't know the y-coordinate, but for this problem I don't need to, right? So that's how I know it has a maximum. The axis of symmetry is always x equals the h-coordinate of the vertex, which I know is -5. So that's how I know my axis of symmetry. And since the parabola opens down, I know that a is negative. Okay, last one. This is very similar to what we did 2 problems ago, except for now I'm just giving you the vertex as opposed to giving you the function. but the rest of the process is going to be the same. So again, I want you to try this on your own. Pause the video, try to do the problem, unpause when you're ready to discuss. Okay, nice work. You did great. Look at this. Oh, sorry. Those are my answers, but I'm assuming you have the same answers, so I'm assuming you did great. If a is a positive value, I know the parabola opens up, so therefore I know that there is going to be a minimum. Domain is negative infinity to infinity. The minimum value is the y-coordinate, or k, of the vertex. The range is k comma infinity, because it opens up, including the negative 11 in this case. It is decreasing to the left of the vertex, and then it is increasing to the right of the vertex, and we label those with the x-coordinates, including, so based on the domain, which is negative infinity to infinity, so I start at negative infinity, I go to negative 3, and then it's increasing from negative 3 to infinity. All right, good practice.